Okie dokie, so today we are going to be looking at our practice test for test 10. So the first question asks to find two coterminal angles for the following angles. So we are given 315, so we can add and subtract 360 to get our answers. So we could go 315 plus 360, and so one of our angles can be 675. And the other one, when you subtract, we can get negative 45 degrees. At 7 pi over 6, if we add 2 pi, you are going to get what? This is going to be 5 pi over 6, and then if I add another 2 pi to this, because you could just keep adding and adding 2 pi's, we could get, think about this, if we go 6 over 6, we'll have 5 pi plus 12 pi over 6. That's going to equal 17 pi over 6. So, we have our angles here and here. So let's look at that up here. Let's look at reference angles. Oh, this is a little wonky. All of our numbers look a little bit weird. Just bringing it into this software that I have. I hope the video is not glitchy this time. So let's think of where 675 is. Actually, we just did a problem that 675 is coterminal up here to 315. So that's a little cheat we got going on here. So our angle is going to be down here at 315. Think about it's going around once, around twice. And now what our reference angle is in between the terminal side and the x-axis. So our reference angle is going to be 45 degrees because we are going to get 360 minus our coterminal angle to 675, and that's at 315 is equal to 45. So down here we are going to have, this is going to be positive root 2 over 2 and negative root 2 over 2. We're finding our 6 trig functions. We have sine is root 2 over 2, cosine, sine is negative, cosine is positive, tangent is negative, cotangent is negative, that's secant, excuse me. Secant is root 2, because when you flip it over, there, I'll just do one. So if we have 2 over root 2, finding the reciprocal, to multiply by root 2 over 2, and that's going to give us just 2 root 2 over 2. That all cancels out. So that's what we're going on there. Negative 2 pi over 3. What's this going to look like? Let's go ahead and graph it. 2 pi over 3 is going to end up... Why's my straight line not working? Down here. Looking like this. If we add 2 pi to this, we're going to get 4 pi over 3. So at 4 pi over 3, our x is 1/2, and our y is negative radical 3 over 2. So sine, we need to look at our reference angle too. I think our reference angle is going to be 4 pi over 3, which is the coterminal angle, minus pi. That'll be pi over 3. So that's our reference angle. Let's not forget that. So our sine, 3 over 2, cosine, -1/2, tangent is sine over cosine, which is going to be negative radical 3 over 2 times negative 2 over 1, multiplying by the reciprocal. So it's just going to be root 3. Our cosecant is going to be negative 2 radical 3 over 3. Secant, negative 2. Cotangent, radical 3 over 3 when we rationalize. So this is all pretty basic stuff. I didn't go into too much detail, but if you cannot do this, I would spend some time on this, because there's a good portion of the test that is, or a good portion of the points of the test is within these two questions. This is like, I believe this is going to be 12 points. I haven't quite done it out yet, but that's quite a bit. So this, just solving, this is straight unit circle. It does have some negatives, some coterminal and stuff like that, so let's just go through it. I'm just going to fill this in. I believe in you. You all know, oops, that's a 2. The unit circle, very well. I trust you. Remember that when we have tangent looking like 1 over 0, we have this undefined, so we can keep that in mind. And you can go ahead and just write U and D undefined. That all works for me. Graphing. Let us graph. So let's look at our amplitude. It's going to be 2, our period is 2 pi over b, which is just 2, so our period is equal to pi. We have a vertical shift of 1, and we're dealing with negative signs, so let's not forget that. Let's use, actually just use black to start out. Really shaky looking graphs. I don't like drawing squiggly lines in this program that I have. So our period is pi. Go ahead and fill in our critical points. And negative pi. Our amplitude we also have to fill in, so this is 2. We have negative 2. We're moving up 1, so I'm going to go ahead and label some more stuff that we might have going on. Negative 1, 1, and then our new max will be at 3. So let's take all of our points and move them up 1. Take all of our critical points. It's going to be here, here. This point goes to here. Oops. Here. It's at 2 goes up top. 0 is going to go to 1. Negative 2 to negative 1. Something like that. And then, as we've done before, let's go ahead, connect the dots. And then I would highly suggest that you just say something like is equal to the red line or the dotted line or the dashed line, whatever you got going on for how you're going to differentiate your two graphs. And you could just leave it just like this. We have our negative, we took into account our negative, we took into account our amplitude, our period is different, and we've moved it up 1. So everything is taken care of, except I still want that this is going to equal our red graph. Okay, so let's actually make sure I know what I'm trying to graph here. I believe this is going to be apologize for this. I believe this is going to be cosine of 2x plus pi, if I'm not mistaken. This is all going to be over 2. Let's keep in mind that we can just rewrite this as 1/2 cosine of 2x plus pi. So now to find my period, or my my phase shift, I'm going to factor to get into that a cosine b parentheses x plus c parentheses plus d form. So we have 2 pi, or 2 parentheses x plus pi over 2, and then there's no d in this problem. So our phase, let's write down what we got. So we have our amplitude is equal to the absolute value of 1/2, which is 1/2. Our period is going to be the same thing we had last time. 2 pi over 2 is pi. And our phase shift is going to be pi over 2 to the right. You might have seen or heard in the videos a slightly different method where you don't do this factoring, and you might do this, I believe it's negative b over c or c over b. I don't quite remember, being honest, because that's not the method that I use. You can do that, that's fine, just kind of disregard what I'm doing there. So let's go ahead and graph away. Need a straight line. Where's my straight line not wanting to work? There we go. So we have a positive function, we have positive cosine, so everything is nice and easy there. Oh boy, that is an ugly looking left side of it. That's alright. 1/2, negative 1/2, we label our critical points, pi over 2, pi over 4, 3 pi over 4, and then the negative versions. Oops, that's a 4. Alright, so we've done our amplitude, we've done our period, and now we have to think about our phase shift. We're moving all of our points pi over 2 to the right. So let's start, where should we start? Let's start in the middle. This over, this over, this over, no, not quite there. Over. I know this is a little bit hard to see what I'm doing because I don't actually have the, like, I can't show you what my my pen is doing, if that makes sense. And then this is going to move over. This is going to move over here. Let's go ahead. Trace out our new graph. Realize if you move pi over 2 over, you essentially get the negative cosine. And that the same thing goes for sine 2. So, simplifying, let's take a look at this. So we have, I'm just going to rewrite this because this is not looking very nice. Okay, so let's look at how we're going to do this. So right away in the top, I see a 1 or a negative 1 plus secant. Now, I don't remember all the Pythagorean triples or Pythagorean identities off the top of my head, but I do know the first one. I do know sine squared plus cosine squared is equal to 1. By dividing by both sine squared and cosine squared, I can create the other two. So sine squared divided by sine squared is 1. Cosine divided by sine squared is going to be cotangent. then 1 divided by sine squared is cosecant squared. If I divide everything by cosine this time, I'll have tangent. I'll have 1, and I'll have secant squared of x. Now, so what do we have here? I see a minus 1 and a secant. So if I look at our last one, I can get tangent of x squared is equal to secant squared minus 1, which is what we have. So we can get that this is tangent squared of x over secant squared of x. Now writing this in sines and cosines, we'll have sine squared of x over cosine squared of x over 1 over cosine squared of x, multiplying by the reciprocal, sine squared of x over cosine squared of x times cosine squared of x over 1. Cross out our cosines, and we are left with sine squared of x. Very good. Next, let's look at something a little bit more fun, in my personal opinion. And when I say more fun, I mean a little bit more tricky. In this one, I see that I have two signs in these two different parts of this expression, and I could factor them out, actually. I'm going to factor out sine squared, and what are we going to be left with? Tangent squared plus 1, right? Factor a sine squared from a sine squared, you get 1. This is of x. And I remember, I see this tan squared plus 1, and that's going to be equal to secant. So if I go sine squared of x times secant squared of x, I know that secant is 1 over cosine. 1 over cosine squared of x. Let's make all these equal each other. And that's going to leave us with tangent squared of x. Which is interesting how we start with this tangent squared of x and this, this other sine and this other sine, and we just end up with tangent squared of x. Interesting. Let us move on. Pythagorean. Oh no, this cut off like half of my problem. I believe that there's a C to this Pythagorean trig identities and what we have going on, but I don't know what it is. So if you have any questions, go ahead and ask this in class. So I have that we are going to be in quadrant 3 because it's in between pi and 3 pi over 2. So we're going to be in quadrant 3 for this. We're given that cosine of x is negative 8 over 17. So let's use, and I bolded Pythagorean trig identities in this because I want you to use Pythagorean trig identities. I'm going to put some on the test saying if you don't use them, I'm going to take points off because you need to be able to know and use this skill. So let's go ahead and plug in what we got going on. So we can do sine squared of x is equal to, nope, not equal to, plus negative 8 over 17 squared is equal to 1. I believe 17 times 17 is 289. Yes. Okay. So we're left with 64 over 289. 289 minus 64 is 225. So we'll get sine squared of x is equal to 225 over 289. So sine of x, when you take the square root of both, you're going to get 15 over 17. So now we have our sine and our cosine. So let's go sine. But the one thing we do have to remember about sine is that we're in the third quadrant, so we're going to have negative, negative. So our sine is still going to end up being negative. So sine is negative 15 over 17. Our cosine be negative 8 over 17. Our tangent is sine over cosine, so we're going to have negative 15 over negative 8. So that's just going to become positive. Cotangent is just 8 over 15 then. Secant 17 over 8. And cosecant as 17 over 15 and make that negative. Let's look at our last problem that we have going on, and I included a blank unit circle for you guys. Not going to be for any points, but it's there for you guys to use it. And I'm sorry about the formatting issues. So we have tan of x in this one. Remember, we have, this is our formula. Let's go ahead and copy and paste and just bring that on down. Just bring this down over here. Why not? So we're given tan of x is negative 3 over 4, and then we are in, what quadrant are we in? We are in 90, 180. So we are up in quadrant 2. We're going to have negative x's and positive y's. So let's look at what we got. So we have 1, negative 3 over 4 squared plus secant squared of x. Let's look at what we got. So we're going to get 9 over 16. It's going to be positive because we're squaring it plus 1. Secant squared of x, which is going to get us, what, 25? I believe 25. Yeah, 25 over 16. Secant squared of x. Remember, there's no calculators on this. I mean, to do this, you just basically make this 1. 16 over 16. They're all going to be numbers that you could do easily. I promise you should be able to do this. And if you don't know how to do this, I suggest you get a little refresher. Take the square root of everything. We get 5 over 4 is our secant squared of x. Now we have to remember what quadrant we're in and what secant corresponds to. Remember, secant is 1 over cosine, and cosine is negative in quadrant 2. It's going to be negative secant. So start filling out what we got. So we got sine, cosine. Our tangent is negative 3 over 4. Our secant, negative 5 over 4. Cotangent is going to be reciprocal. So 4 over 3 negative. Negative 4 over 5. And then what do we have up here? This is cosecant. To find what sine is, you could just take cosine and plug it back in, or you could know that tangent is going to be sine over cosine, and that this is a 4-5 or a 3-4-5 triangle. So we just get that this is 3 over 5 from that, and 5 over 3. Alrighty, that is all I have for you guys today. There is one more question, I believe, about Pythagorean trig identities on your guys' test. The formatting issues, bringing it into my sophomore, this notability, it just doesn't really like the math type or anything like that. That's why we got all this funky looking stuff going on. If you guys have questions, please don't hesitate to email me. I'll try my best to get back to you as soon as possible. I'll be here before and after school if you guys need help.